The first exam question in this circular measure lesson is a question that still involves sine, cosine, and the tangent and the relationship between them. So it kind of makes a transition between identities and the proper circular measure questions, but there's a chance that you will find them in the exam. Okay, so is this one over here? This is from May-June. Give me a second. Yes, May-June 2015. It's paper 11, question 1. It says this: given that theta is an obtuse angle, and here the key word is the obtuse, measured in radians, and that sine of theta equals k, find in terms of k an expression for a cosine of theta, tan of theta, and sine of theta plus pi. All right. Again, like most of things in trigonometry, if you have a good visualization of the trigonometric circle, that is, if you reach the exam knowing by heart the trigonometric circle and the relationship, the actual visual relationship between sine, cosine, and tangent, these questions are not going to be difficult at all, because you can always make a little sketch of the trigonometric circle and figure things out yourself. All right? How are you going to, what formulas are you going to use to relate sine, cosine, and tangent? The only ones that you know are sine square of theta plus cosine square of theta is 1, and sine over cosine of theta equals the tan, okay? But this is only true if the angle is an acute angle, because these two formulas are derived from the rectangle triangle that is created, that is formed in the unitary circle, in the trigonometric circle. So if you have an obtuse angle, you won't have anymore that acute angle from which these formulas stem from. Okay, so you need to do what? You need to visually understand how the obtuse angle can be related to the acute angle. I'm talking too abstractly, so let me go straight to the diagram that I already did. Okay, so this is what you have. You know that theta is an obtuse angle, so it's bigger than 90 degrees, all right? So it will be, I just put here this line over here. You have this line also, but bear with me. And right now, look only at this one. So this is the theta over here, starts from obviously 0, goes over the pi over 2, the 90-degree line, and it's this over here, right? So this is no longer, this can no longer create a rectangle triangle to get the two identities that we saw a little while ago, okay? But from this angle, you can see a couple of things, a few things. First, you can see that the sine of this angle, which is k, is measured over here, is this thick line over here, the vertical thick line, okay? And you know that the cosine of this angle is this bit over here, right? This thick line over here. But how big it is? How big is it? And how does this relate to that? You need to use this equation. But again, this equation only works if the angle is an acute angle and theta is not. But you can very quickly understand that you can think of an angle alpha, the one I've drawn here, that is going to be equal to this one. This one is what? Is 180 minus the theta, right? Okay. And you know that this angle over here, this alpha over here, is the angle that whose sine is exactly the same as the sine of theta, right? If you measure the sine of this angle alpha, is the same value that you have for the angle theta. Okay? Now, if you look at the cosine of this angle alpha, is going to be minus the cosine of the angle theta. In other words, the cosine of theta is going to be minus the cosine of alpha, or the cosine of alpha is going to be minus the cosine of theta. So if you can measure the cosine of alpha, you immediately have the cosine of theta. And the cosine of alpha is very simple to measure, just using this. Okay, the cosine of alpha is going to be the square root of 1 minus the sine square of alpha. And sine square of alpha is the same as the sine, and sine of alpha is the same as the sine of theta. Make sense? And sine of theta is what? Is k. Make sense? This is what I did over here. The cosine of alpha equals square root of 1 minus sine square of alpha. So minus cosine of alpha, minus cosine of theta, that's what cosine of alpha is, equals the same thing. And the sine of alpha is the same as the sine of theta, which is k. So I just substitute over here, and I have the final answer. The cosine of alpha equals minus square root of 1 minus k squared. I think that this is more complicated to explain than actually visualize. That's why in a mark scheme, this is only a 1 mark question. Actually, this one is 2 marks because you have to apply this formula. I would actually put more marks if it would be me doing this exam. I would put more marks on this question, at least the same as on this one. Okay, but if you make a little sketch of the trigonometric circle and you understand how these angles relate, then this will be much simpler than it is if I try to explain verbally. All right. Anyway, this is the value of the cosine of alpha. What about the tan of alpha? Now that you know an expression for sine and cosine in terms of k, you know that tan is sine over cosine, so just substitute the values, and this is what you get. What about the sine of theta plus pi? Again, don't memorize stuff, just understand what is happening to the value of the sine if you add to an angle half of a circle pi. So right now you are here, okay? And the sine of theta is k. If you add half a circle, 180 degrees, pi, where do you end up? You end up over here, right? I didn't draw it, but the angle would be this. And where would the sine be measured? Again, in the y-axis, it will be over here. It will be a line starting over here, going over here. And how big is this in length? Is the same as that. But because it's pointing in the opposite direction, it's going to be minus k. All right? Again, I cannot stress enough the importance of you knowing by heart, just because you used it so many times, the trigonometric circle. So I told you before, take time to build your own trigonometric circle. Do it yourself with compass, rulers, etc. Do it as neatly as possible, and spend some time taking care of it and using it in every single exam, because I can guarantee that happened to me when I was a student. You will own it in a sense that will become part of you, and trigonometry will become much simpler. Okay? Now, let's go to other questions. These are already proper circular measure questions. The next one is this one. You have AB. AB is an arc of a circle, center O and radius R. Angle AOB is theta radians, and the point X lies on OB, and AX is perpendicular to OB. Show that the area A centimeter square of the shaded region AXB is given by this expression. As you can see, there is no numerical value whatsoever in this question. Everything is as abstract as using the formulas. And then only on question 2, you are given values and you have to calculate something, the perimeter of the shaded region. Okay, so let's take care of this first. So the perimeter of the shaded region is obviously the perimeter of this arc minus the perimeter of this, the area of the shaded region is obviously the area of this sector minus the area of this triangle, right? So let's take care of each thing at a time. The area of OAB is the area of the sector is given by the formula. The area of OAX is going to be base times height divided by 2. So OX times AX, this is 90 degrees, divided by 2. What is OX? OX can be expressed with a cosine knowing the value r, so it's going to be r cosine of theta. And AX is going to be r sine of theta. Don't forget, you need to provide a final answer in terms of all these things. So here you have it, the area of the triangle. This is the area of the sector. So the area of the shaded region is this minus that. Factorize 1/2 of r squared, and this is what you get. Now you are given the value for the radius, r as being 12, and the theta as being pi over 3, and you want the perimeter of the shaded region in terms of square root of 3 and pi. So that's going to be ax plus xb plus ab. Ax, as we saw before, is r sine of theta, just substitute by the values. Xb is going to be OB minus OX, and OX, as we saw before, is r cosine of theta. OB is just r. Okay, don't forget, this is a sector of the circle, so OB is the same as OA. So that's what you're going to end up with. And AB is just this arc given by the formula. You know the value of theta, you know the value of r, so it's going to be just 2 pi. So the perimeter is given by this expression over here, simplified, and this is what you get. Last question is this one, is from Winter 15, paper 11. From all the ones I solved for these lessons, this is the one that takes more time. It says, the diagram shows a circle with center A and radius r, diameters CAD and D and BAE are perpendicular to each other. A larger circle has center B and passes through C and D. Show that the radius of the larger circle is r square root of 2. The radius of the largest circle. So I just call it BC or BD. Okay, I've drawn it in my own diagram. So it's this. I called it the big uppercase R. And you need to prove that this is equal to r square root of 2. If you actually draw it, this is going to become obvious because now you will have here a rectangle triangle, right? So you can express this hypotenuse using Pythagoras theorem, knowing these two sides, which are both r, right? Look at the smaller circle. This is a center, so this is r, this is r. So r squared, big R squared, equals the sum of the two little r squared. Okay, so that's how you get the value that you needed to prove. What about the area of the shaded region? That's the second question. The area of the shaded region is the area of the small circle divided by 2. I just broke this down into this semicircle, all right? So it's the area of this semicircle minus the area of this part over here, CDF. I added this letter F. You can do that, yeah, as long as you keep a diagram of that. Not, yes, now you give in the exam question, so you can make the little spot there, as long as you identify it, as I did over here, this extra point, as I did for this uppercase R, you can use those letters, okay? The area of the small circle is basic because it's just using the area of a circle in terms of r and dividing it by 2. The work comes trying to figure out this area of CDF because you don't have an explicit way to get this in one go. So you have to go and figure out a way, right? I myself, when I was trying to look at this question, I spent a couple of minutes trying to figure it out myself. So if it's not obvious to you in an exam, don't worry, don't stress, that is normal, okay? You just have to look at it, try to divide it mentally, figure out ways of getting what you need, all right? So what did I do? I know that the area of CDF is going to be equal to the area of the sector BCFD. Where is it? Is this one over here, BCFD. This is a sector, right? minus 2 times the area of the triangle ABC. Where is A? ABC. So look at this. I have this area of this sector over here. If I take the area of this bigger triangle, which is made out of 2 times the area of these two smaller triangles, then I'm left with that, which is the bit that I want. All right? So that's what I did. The sector, the area of the sector BCFD is given by its formula, right? In which theta is just pi over 2, is that bit over there, all right? You need to know that as well. I've drawn these two lines, and I need to understand that this is going to be pi over 2. And how do you know that? You know that because if this is this length over here and this length over here is the same for this smaller triangle, then it means that this angle from here to here is pi over 4. Is 45 degrees, right? So if this is 45 degrees as well, the whole thing is going to be 90 degrees or pi over 2. All right? So that's where this pi over 2 comes from. All right, so what else do we need to know? We need to know that, where am I? Okay, so the area of the triangle ABC is going to be base times height divided by 2. So r times r divided by 2. So that's r squared divided by 2. But since you have two of them, that's just r squared. Okay, now you have expressions for everything. This is going to be, well, this is just algebraic manipulation, right? I'm just substituting. Let me see if there is anything else that you need to know. Well, here on the big R, on the uppercase R, I put the value that I got a little while ago. Okay, square root of 2R. So I have now everything in terms of R and pi, lowercase r and pi. So here, this is the area of CDF. The area of the semicircle is given, as I said before, by pi r squared divided by 2. If I take this out, then I will eventually end up with just r squared.